So I've taken last week's work, and what I've done is, and what I'm trying to do is really reduce the really complex words that we use within physics and try to put it in a language that I think, or I actually, the truth is, I know that year 7 can access. So we've been working with springs and the elastic potential energy. But I really want to talk about the kind of words we use, how it relates to the ideas. And maybe because I come from a world where, you know, doing a lot of engineering, doing a lot of things in technology was very big in my school. And I remember putting things together and making circuits in year 7 and year 8 and things like that. And, but, as I got older and as I had my own children, and some of my children are your age, I kind of realized that, there are really easy ways of explaining quite tough things. So, what I mean by tough is adults think they're tough and actually they're really not. So, I'm going to go through the keywords. A force, right, is a push or a pull, right? Or even if you think when you squeeze something, you're pushing them together. So, when you push or pull something, it is a force. That's it. The units are newtons after Sir Isaac Newton. Now, an extension is a very particular word we use, and to do with springs or elastic bands. This is what we looked at last week. The word, it's how much longer a spring gets when you stretch it. So I've now moved on from elastic bands to springs. They're literally the same thing. The difference is you can squeeze a spring as well. You have something called the spring constant. It tells you how stiff or stretchy a spring is. The stiffer the spring, the bigger the value, right? And then we talk about, springs being stiff. Well, what do I mean by that? Well, if you get a big metal spring, it's really hard to squish it or stretch it. Now, elastic, we talked about that last week. It's a material, like an elastic band, that goes back to original shape when you stop pulling it. Now, Hooke's law, he was a scientist, right? And it's a really simple rule. It says if you double the force, if you times the force, or if you stretch it twice as hard, you will extend it twice as far. Right. And it's got this really interesting rule. And this is true for Hooke's law. And again, it's got a really funny, set of words. You've never heard of Hooke's law. I don't mean fishing. So that rule, if you double the force, you double the extension, we have this really interesting formula. The force is equal to spring constant, which we call K, times how long you've extended it. That's it. Right? Stiff springs, as I said, have a really, really high spring constant. That means this number is going to be very, very, very big. Right? So K for it's going to be very, very big. And we're talking about things like the springs inside a car. They hold the entire car up. Weak springs have a very low spring constant, so they'll have a really small number, like 0.01 or something. And that's like, if you've got a clicky pen, there's a little spring in it. Well, it's not very strong, it's not very stiff, it's very weak. All right? I also want to talk about graphs. Now, when you guys will look in books and stuff, you'll have a really, really horrible graph like this. Hey, it looks mean. It's got words like that and that. So I wanted to take something, I wanted to explain it in a way that I explain to my children. So, this is extension. Well, how far has it extended? And this is the force. Okay. So what it means is, when your line is straight, it's been a good spring. It's been a very good spring. It's a very good spring. It is obeying the law, Hooke's law, that if you double the force, you double the extension. And it's been a really, really good spring. It's obeying the law, right? I can tell you how much force I'm going to be. I'm going to tell you how much it's going to stretch, all that kind of thing, right? And the reason I know is it's a straight line. That's it. It's a straight line. Well, obviously you know what a straight line is because I've just drawn it. It's a straight line. And it's been a very good spring. It's doing what it's supposed to do. If you pull an elastic band too far, it stretches and too much and breaks, and it starts doing this. Now, that is not a straight line. Right? It doesn't have to be exactly that shape. It can be any kind of shape. But that's not a straight line. Right? Now, it's been a very bad spring. It's not doing what it's supposed to do. That's called the limit of proportionality. We looked at last week. And it's been and actually two things are going to happen. It will never go back to its original shape. Right? Or it will break. Right? Okay, well that doesn't say original, does it? And the other thing, it always has to start here, in the little corner that we call the origin. Why? Why does it have to start there? Well, if you've got a spring and you put no force in it, if you do it, well, it shouldn't extend. It shouldn't get longer. And that's it. All right. Now, as per usual, okay, I'm going to put this in the drive. The first 10 questions are based on the information I've just said. And I'm going to go through them, the easy ones. It's based on everything here. All right. What unit do we measure force in? That's the Newton, it's the first one. If a spring is 10 centimetres long and you stretch it to 12 centimetres, what's its extension? Well, it's 12 minus 2. It's got 12 minus 10, I'm doing the maths in my head too fast, equals 2. So its extension is 2 centimetres. All right? That's it. What do we call a material that returns to its original shape? That is, here, elastic. A material that goes back to its original shape when you stop pulling it. Does a stiff spring have a high or low spring constant? Well, it's a stiff spring. All right? And that's down here in core information. Stiff springs have a high spring constant. What piece of equipment do you use to measure the length of a spring? A ruler. If a graph of a stretching spring is a straight line, is it following Hooke's law? Yes. What is the name of the rule F equals KE? Hooke's law. What happens to a spring if you pull it too hard? It breaks. If you double the force on a spring, what happens to the extension? It doubles. What is the unit for the spring constant? Oh, it's not there. I'm going to put that one in. Newtons per meter. Newtons per meter. All right. Then you get to number 11. A spring has a stiffness of 10 newtons per meter, K, and it stretches 2 meters, right? And you're trying to find the force. So you write F equals K times E. Well, where did I get that from? Well, it's right here. F equals K times E. F stands for force. Oh, we're trying to find force. That's equals to K. They gave me K. 10 times extension, 2. 10 times 2 is 20. It is a force. The units of force is newtons. Dun, dun, dun. You're done. Okay, now I really like this because you start learning that physics isn't that tough. You only times two numbers together. You're just learning the language of physics. All right. Oh, 9 minutes. Slow.